G'day guys. People keep on asking me how much vitamin D should I take, what's the sort of dosages, the range and stuff like that. So there's a lot of confusion out there and stuff like that. And I always go to first principles when it comes to anything, whether vitamins, minerals or whatever. I always go, what's your excretion rate? What's your intake? What's your activation or deactivation? What's really the body doing? Somebody in a natural environment, what sort of levels are they getting? This is the sort of stuff that people should be asking. I mean, a lot of people sort of talk about the RDIs and talk about this, and I don't talk about that. I usually basically go to the crux of the matter. It's like magnesium. You got 120 milligram excretion rate per day. You need that and just slightly a bit more, just in case you may require a bit more. Most cases, if you're on a species appropriate diet, you'll get probably double that. I usually get sometimes even triple that. So it's a non-issue. Likewise, when it comes to vitamin D, we also have to look at what are we getting from the natural environment. So if I expose myself, to the sun, and if I'm basically in Africa, in a very warm, hot environment, I will probably generate, but it will take me quite a few hours, up to 6 hours, to generate anywhere between, 15,000 IUs up to potentially 20,000 IUs. Can vary. But in most cases, I mean, even if you look at the Maasai, they usually are in the range of nanograms. They're around about the 40, 46, some of them 42, some of them a bit higher, depending. But generally speaking, it's not, when you're looking at people with a fairer skin, especially in the tropics, it can be much higher than that. It can be up to the 60 range or above. That tells you that skin tone does play a role in that regard. And, the amount of melanin does affect how much you can produce within a given day or whatever. Somebody with a fair skin would probably only need half an hour to an hour to produce equivalent levels. So substantially less time in that regard. But generally speaking, there's another aspect to it here. Now, when you actually produce vitamin D in the skin, and this is an important issue, you don't basically, there is what I call the efflux or the flux. That means the rate at which something gets converted and the rate at which something actually gets into the bloodstream towards the liver to get converted into the storage form. Because normally in the bloodstream, you only have about, around about at max, around about 3+% of what is called free vitamin D. And that sort of saturates a whole lot of receptors in your body. Obviously, if you've got an illness or a cold or some other pathogen issue, the requirements go up dramatically because your immune system pops into the system and it will tap in to the stored amounts and start utilizing them very rapidly and depleting them at the same time. I usually tend to sort of approach those sort of situations, putting in the vitamin D and repleting it, because it can take a number of days for that conversion to happen. I don't expect the vitamin D that I'm actually taking is actually doing a lot. But what it's doing is it actually is, encouraging the body to use more of the stored stuff, because it's saying, well, we've got plenty coming in. We don't have to worry of, rationing, so to speak. And it just basically will flood those receptors with 25-OHD and, basically get it down to the kidneys, convert it to the active form 125, and basically push it out into the tissue to into the immune system, to these systems to basically utilize. And so that's the sort of important element that we need to take into consideration. Now, I'll just share my screen for a sec. Okay, so this is somebody exposed, 30 minutes, midsummer, in Oslo of Norway for 30 minutes, and their exposure gives the whole skin surface is equivalent to taking 10,000 to 20,000 IUs oral vitamin D dose. Okay, so that's what you're getting. But this is the important thing. You're not getting it all in one hit like you get it in a supplement. And that's important. You're getting it in a much slower rate, which is actually, you're basically converting cholesterol into pre-vitamin D, and then that will go at a certain rate. There's a rate limiting, a certain rate into the bloodstream, to the liver, to basically be converted to 25-OHD for storage. If you're not going to be using it, well, if you crook, you'll probably end up using more of that because pretty much the immune system will take up a lot of that sort of stuff. So that's the sort of crux when we're looking at these sort of things. Now, there are other issues involved with this, and this is really important that we understand this. There are liver issues. So if you've got a bad liver, that can cause problems. So vitamin D is becoming increasingly accepted as an important physiological regulator outside of its classical role in skeletal homeostasis. Obviously, a growing body of evidence connects vitamin D with hepatic disease, liver disease. This review summarized the role of vitamin D in liver homeostasis disease and discusses the therapeutic potential of vitamin D-based treatments to protect against hepatic disease progression and improve response to treatment. While preclinical experiment data is promising, clinical trials around liver disease have mostly been underpowered, and further studies will be required to clarify whether vitamin D or vitamin D analogues have beneficial effects on liver disease. What they mean is they've been giving them the RDIs, which are just barely enough to basically protect you from rickets and stuff like that. So it's just crap in that regard. So that is quite clear. In addition to the classical role in bone and calcium homeostasis, there is an expanding volume of data regarding associations between vitamin D deficiency and several medical pathologies, including multiple sclerosis, Alzheimer's disease, myopathy, and cancer. Liver disease has been strongly linked to vitamin D deficiency and the development of vitamin D receptor VD knockout. So that's a knockout mouse model. Murine model was greatly increased our understanding of vitamin D's role in the liver. Vitamin D deficiency is common in chronic liver disease. Surprise, surprise. However, despite several impressive in vitro, petri dish, and in vivo in organism studies using human live cell lines and animals, obviously we cannot experiment on humans. We can only experiment on human in vitro liver cell lines, and the ease of access to vitamin D supplements and analogues. Patient clinical data thus far remains inconclusive because they're using low doses. Studies involving vitamin D interventions in liver disease, like other diseases, have tended to be small and have not yielded definitive results, obviously because one, you've got a small sample size, two, you've got using a lot of them are basically using all the RDIs at very low dosages, and it's just not enough to do the actual job. Giving somebody who's deficient a bit extra vitamin D isn't going to really do it, especially if it's a small amount and you're not saturating. This review aims to update the reader on the functions of vitamin D in liver analysis, any roles for vitamin D treatment. I'm not going to go into that. I'm just basically pointing out that there is the liver axis. So people who are, it's not only people who are overweight that may have an issue with vitamin D, because obviously if you've got more fat cells, you can double the supplementation basically, or even go higher if you're deficient, because your body's going to be sucking up quite a bit of it, and that's the reality. So but at the same time, if you want to convert to the part of that to the active form, 25-OHD, so you can store it, so it can be available when you need it, your biggest issue is going to be how healthy is your liver. That's another issue there, which is very important. Let me just go to this study. It's a pretty good study. Michael F. Hollick, some people know him. He's a pretty good cluey sort of guy in this sort of stuff. Let me just find the part that I... That's not the part. It's actually in this study. Let me just... here it is. Okay, so pretty much, let me zoom into that, open it up. Trying to remember when I read this earlier. This is just my links stored in the folder. So I've been promising to do this for a while, but so trying to remember where everything is since last time I read it. So as you can see, pretty much sunlight. You need cholesterol to basically create the pre-vitamin D3 form. So, and obviously that'll be converted to vitamin D. So obviously you can also get it in the dietary form, fish, dairy, fortified foods. That usually fortified foods is D2, which is there's another rate limiting sort of part which has to be converted. It's not shown in this diagram, but anyway. And then you've got this pathway, which is an enzyme which is involved in the conversion to 25-OHD. And then let me just eliminate that. And then you've got this enzyme here to be able to convert it to the 125-OHD, or some of it, some places call it OHD3, all that to indicate the type, but for short, they do call it 25D or 125D, but I don't like using that. I do like using the full 25-OHD. Anyway, so kidneys have got this enzyme and they'll convert it to that, and obviously it's used by the bone, immune cells, and liver cells. And bile plays an important role in the inactive metabolites, okay, and reabsorption. Also, there is another enzyme also that's involved in the inactivation and excretion. So any excess of the active form, the kidneys will get rid of it with this enzyme here. So any issues with these enzymes, any sort of rate limiting effect, or things either slowing down in a sense, can create issues. They're very rare, but they do exist in some people, and they can actually, if somebody's got a disease situation and they really need, sort of let's say the conversion, they may need to take an injectable form. Like if on the other hand, they don't have something like that, then they may still have an enzymatic issue here, turning the active, the stored form into the active form. Again, there are injectables for that, but they are quite expensive. Those ones they're used in the medical field, in hospitals and places like that. Very hard to get your hands on them, but standard 25-OHD, the storage form, much easier to get your hands on them in that regard. So we'll move away from that, just to give you a bit of a general overview. This is not a biochemistry class. It's not meant to be. It's just basically giving you a general overview of how this sort of, and the sort of areas that can be affected. Kidney disease and liver disease are the two main areas. Just wanted to point those out, that there are issues associated. And so people may have to also, you know, like I've shown the liposomals in regards to what I was doing, the Novavax stuff, but I showed liposomals or liposomal preparations, and that brand that I actually showed you in vitamin D, people have malabsorption issues. That one's pretty good, and it actually can get through, you know, even the blood-brain barrier, and everywhere it can saturate tissue very easily in terms of both free and as a liposomal thing. So that's fairly good as well, just to consider with people that may have malabsorption, gut issues. So keep that in mind. You know, you may have an older mother or father that has malabsorption issues, is a nursing home. You can get them the liposomal form. Anyway, let's move on. Okay, now back to here. Generally speaking, I'll just touch on a few aspects here as well. There's the mass eye exposure, 46 nanograms per average. There will be some that are, there are studies that actually show them down to 42 and others that show them slightly higher. But this is sort of the more realistic average one. Hollick did a pretty good job in getting that sort of data together. So he's very reliable in that regard. But obviously, you know, sort of serum levels and stuff like that, very much affected by, you know, your latitudes and stuff like that. And just bear with me for a sec. When you're looking at sort of cancers between cities, as you can see, the ones that are closer to the tropics have got per 100,000 have got lower rates of cancer. These are associational. Let's not always remember, but these are back in the 1908 and 1912, which obviously people were outdoors far more. So that's an important thing. So people basically in, you know, in these closer latitudes, closer to the actual equator, you're looking at, you know, 13.6 or 11.6. And actually even you can see lower in the actual southern hemisphere. That's not surprising. Remember, the Earth is on an axis, and obviously the sun is stronger in the southern hemisphere. You know, so that's an important thing as well that that people don't seem to miss sometimes. And so you're going to get better vitamin D from the environment. And remember, these people had no, back here, 1908, 1912, less exposure to seed oils and stuff like that. So they were less likely to burn. It's more of a modern phenomenon in that regard. And pretty much you can actually see as you move away from the equator, in the southern hemisphere, it goes to 30, you know, to the 80 something, then 90. But you can actually see up here in the northern hemisphere, the numbers are slightly higher, you know, 105, 108. Even the higher latitudes slightly less, but that's just, you know, different population groups. There are going to be variability in that regard Again, here, solar radiation index, the more you're exposed. There's the US states. The ones further north have got higher cancer mortality rates. The ones that have got higher exposure, lower. So it's pretty good correlation there. Again, here, solar radiation exposure, you know, much lower levels. Colon cancer, much higher in the people that have got less solar radiation exposure. You know, so stuff like that, which is interesting. It's a pretty good one as well. There's a lot of scatter here, which is, and that's understandable why this is. You know, the sort of, there's a mortality rates and all that. Again, more UV, lower rates. But obviously you get this scattering, you don't get a tight. And because, you know, some people are indoors, even in these southern latitudes, in these, you know, hotter latitudes, or, you know, closer to the equator, people stay indoors. You know, so there are these factors, and they do play a role. You know, and this is between, you know, 70s and 95. And so I wish it basically they'd separated this and not sort of lumped it all together, because it creates this really poor scattering effect statistically. I suspect if you had more of the 1970 data, you would have probably got a, you know, a much better result in that regard. It would have been tighter, because back then people were working outdoors far more than they are nowadays. So it's not only, you know, yes, you can get records of UV records from, you know, the different meteorological organizations in the different countries, and know what, you know, the sort of exposures and stuff like that. But still, you know, it's highly confounded. There's issues there, and I'm not really happy with those. I mean, you can, this is pretty good, showing prostate cancer. Remember what I said? Vitamin D in both breast and prostate cancer. There are enzymes that inhibit proliferation of tissue, and that's really important. Actually, the only time the one in the breast is actually suppressed is when a woman is pregnant and needs to grow a bit of breast tissue and more milk. But in normal cases, it's suppressed, and vitamin D plays a big role is the primary receptor. Retinol plays a secondary role, and the same thing exists in prostate, and this is prostate. You know, before is it? Hold on. Yeah, prostate cancer. So I'm trying to remember these, because it's been a while since I've looked at the study. So as you can see, as you get older, but you can see here it actually starts much younger, before 60. So in those sort of people. So the more exposure, the longer it takes before it becomes an issue. So now, let me just stop that. We don't need that. The rest is in my head. Now, when it comes to what do I recommend? Obviously, I recommend a species-appropriate diet, so you're at least getting a couple of thousand IUs, anywhere between 3,000 and 6,000 IUs of retinol to balance out the vitamin D. But when it comes to supplemental vitamin D, I usually tend to go for the low of, you know, like 5,000 IUs. If somebody's wanting to basically push it up to 10,000 IUs, I don't have a problem with 10,000 IUs, as long as they basically add it in smaller doses. Like, you know, they have 4 or 5,000 IUs as one dose, and then 4 or 5,000 IUs as another dose, so they don't have one big hit. With Dad, he basically just, because he gets outdoors all the time, so I just get him to basically have 2,000 IUs, and having one earlier and one later. So it depends also how much you're outdoors, you know. So if you're outdoors, even in winter and autumn and spring, you'll get some vitamin D. If you're actually eating some vitamin D as well, you know, Dad and me tend to consume, you know, both eggs, both seafood and stuff like that. So we do get quite a bit in the diet as well. And as a consequence, where, you know, also pork, we consume quite a bit of pork, and in pork skin, free range, we get, you know, I've shown you my stuff, the stuff that I get is all free range. That's basically, you know, foraging. So it's out in the sun. So it's got more vitamin D in it. So I get a certain amount. And so I tend to basically go for the 5,000 IU. And I usually just have one for the day, and I've got the rest from the food. So probably all up, probably getting, you know, a couple of additional thousand from all the foods that I consume on average. So I'm probably on averaging out about 7,000 or something like that, which is fine. The only time I actually up my dose is when I get some cold. If I get a cold, I'll dramatically jump for a couple of days up to 20,000 IUs. And I'll do that for a couple of days, and then I'll drop back to 10 for the remainder week, and that'll be it. So you have to think, what would I get optimally through the different parts of the year? You'd probably average out about 5,000 IUs, most adults. So that's why I sort of pick that. You'd get a bit in food. Remember, it does fluctuate seasonally. So basically what you're doing is you're maintaining a sort of a more steady state in terms of averaging out seasonality. That's what you're doing. Very important that you basically do get out in the sun, even in winter when you're not producing a lot of vitamin D. Why? There's another element there, cholesterol sulfur. So very important. I will cover cholesterol sulfate in a future video and sort of cover the benefits of it and the importance of exposing your skin to sunlight, both winter, autumn, spring, and summer, obviously. The sun is more than just vitamin D in terms of benefits. Very important for nitric oxide synthesis, and also very important in a number of other respects. Now, two other important aspects is that if you use, you know, like sunscreens and stuff like that, obviously that will inhibit, and it won't only inhibit cholesterol, vitamin D synthesis, and also affect. So if you basically, let's say you've been out in the sun and then you decide to put lather yourself with basically this, especially the zinc type, or the, you know, those sort of can be very problematic. They can interact and affect the actual absorption. They can actually reduce the absorption, which is one negative thing. And then the other thing they can do also is they can actually affect the cholesterol sulfate that's being produced. They can suppress it quite a bit. Combination with glyphosate, they can really degrade it quite a bit. But that's for another day, as I said. The key thing is to understand that, you know, the natural human way is getting it from the sun. But at the same time, you know, if you look at those latitude information, we originated in those warmer latitudes, in those warmer part of it. We spread around the planet. We tapped into certain things, you know, species appropriate foods. The problem is a lot of our food supply isn't what it was, or we can't actually get access to the same sort of stuff. If I was basically living amongst the Inuit, I'd be basically tapping into seals, and because seal fat is very high in vitamin D. Same thing with, you know, and they use seal fat to cook. So there were natural foods in that environment that provided that. We now live in an environment where we can't access a lot of those foods. And that's where supplements come in. It's not because I'm a promote, you know, I don't promote like promoting supplements. I believe you can get it from the food, but the biggest problem is the types of food we've got access to are not the types of food we had access in those sort of environments. So we can't tap into that. Some people still in places like Iceland and all that still do hunt some of these animals and do actually access, but the majority are city slickers, living in the cities, have very little access to those foods nowadays. There may be certain types of foods that they can get in certain types of specialty outlets or whatever, but it's limited. Even in those countries that have got access to these type foods that have those benefits. For people like myself, pork skin, especially pork that's basically foraging, free range. And obviously, we don't want sort of pork that's been fed industrial crap either. So that's very important. I know it's really hard for people in North America because the supply there is very problematic. I realize that. I'm cognizant of that reality. And I understand. And that's why I do recommend, because like in autumn and spring, I sort of usually drop the supplements completely. But I've got access to the sun. I get outdoors. I eat certain foods that are very high in these, that are for animals that are foraging, that are clean. That's not possible for everyone, and I realize that. I understand that. I'm quite sensitive to that reality. So what I'm saying to these people is, guys, get at least on average within those periods of the years you've got very little exposure, on average around about the 5,000 IUs. You'll get some from your foods, from your animal foods that you consume. And so that should cover you. Now, if you basically come down with something like COVID or something like, some severe respiratory thing and all that, go and get yourself injectables, 10,000 IUs, do at least 3, and that should clear you up. Even Mira did 3 when she got COVID, and it sorted it completely. She was back to normal within a couple of days. So works pretty fast when you get the active form. You don't have to convert it, which takes, can take a few days. Some people it can take up to a week. Others I've heard of situations, really slow converters, up to 3 weeks. It's quite rare. It's usually only the majority of people within that week. But still, you can get into a very severe sick state within a couple of days with insufficient vitamin D levels. And your immune system can really tax your stored vitamin D. So it's very good to basically provide a boost. And because remember, it's plays over nearly 1,000 different biological functions, involved in a lot of different biological functions. So it is required. And there is a demand on other systems as well, not only the immune system. So it's really important to maintain good vitamin D status all year round. And at the same time, if you've got something, a severe respiratory infection of any, of any sort, basically any of the corona family of viruses, pretty much hit yourself with big doses of vitamin D. Take 10,000 IUs for a couple of days. And when it comes to COVID, if somebody's older, and depending on how fat they are and stuff like that, even up to 50,000 IUs for a couple of days, like 3 days or whatever, and then back down to about 10,000 IUs for the rest of the week. If somebody's morbidly obese, you may have to go 50,000 IUs for a whole week or a bit more, because it's just the amount of adipose tissue they have, and they'll absorb a lot of that in the adipose tissue. Same thing goes if somebody's very overweight and losing weight, they will be releasing a lot of fat-soluble vitamins. So they need to sort of restrict the intake I know it sounds bizarre, but they need to, because I'll be flooding their body with quite a bit. And a lot of these people also have a number of underlying conditions, like a poor liver. So when people talk about toxicity about these things, it's usually due to poor liver. That means damaged livers, fibrotic liver cannot hold on to retinol. Okay, so it dumps it as well if you've got too much damage. Same thing with vitamin D and vitamin D conversion. There are a lot of issues involved with liver health and all that sort of stuff. That's why I usually say very important to use, if you've got liver issues, to use, obviously, to break down the fibrotic tissue, taurine. So you'll go for the sort of 5 grams at a minimum. If you've got blood pressure issues, remember, slowly, and adjust those meds. If not, you can go a bit faster, go up to 2, then 3, then 5. And the other thing that is important is R-alpha lipoic acid. And you want the R, the natural one, not the other one. Okay, so you want the one that actually does the job, not the other, because there's the S version and the R version. So the R version is the one we want in terms of alpha lipoic acid. Really important to get it in there to heal the liver as well. So you throw that in. MK4 also plays an important role, but it's sort of a minor role. Milk thistle plays a bit of a role, but it's a sort of, again, a minor role. My biggest focus is I just usually throw the sink at the job in a thing. But if I was going to pick anything, the 2 main supplements that I would pick would be alpha lipoic acid and basically taurine. That would be my 2 favorites. And the other one, which is really important, is choline. And choline helps export the fat out of the liver. So initially, you may not get very good results in terms of getting rid of fat droplets if you go in and scan yourself, because you've still got some damage, some fibrotic tissue. The liver isn't functioning well, so it can't utilize properly choline as well. But eventually, as the liver heals with taurine and alpha lipoic acid, then the choline will start exporting at a more rapid rate, getting rid of the fatty deposits and fatty droplets in the liver, and that will improve over time. B vitamins are very important as well. I've already talked about B vitamins many times, about how to fix your B vitamin status with your gut microbiome and other things like that. And most animal foods are very rich in B vitamins. So if you're eating species appropriate, you shouldn't have a problem with B vitamins. It's really a biohack of 3 months with vitamin D just to fix your gut microbiome. If you weren't to do that biohack, it would just take longer to heal the beneficial bacteria, bring a lot of them back. Usually when you get rid of the sugar and crap, and provide good nutrition to the body with all the micronutrients from good animal sources, usually it does recover. It just takes longer. So the only reason we do biohacks is not because we're just trying to limit the time rather than anything else. Naturally, people would have maintained very good vitamin D status all year round because it'd be outdoors all the time. We don't live like that anymore. So we have to find other sources. That's where supplements come into. Now, when it comes to supplements, really important. No seed oils, okay? Check the pack. What does it say? If it's got basically olive oil is sort of my, I usually basically, if I'm going to buy anything, it's going to be with coconut oil or MCT, something like that. Unfortunately, they don't put bovine fats in there or anything like that, but pretty much the only oils I would consider. The other option is to get an oil-free. You can get oil-free vitamin D, but that means you need to combine it with animal fats. Obviously, you can combine it with, cream or butter or, a bit of, animal fat. So it's up to you how you combine it and to help with the absorption. That's sort of an important element, as I said, with malabsorption issues, liposomal, stuff like that. So that's another issue in itself. But generally speaking, don't go into the high quantities. You don't need to go into, there are therapeutic for specific conditions. When somebody actually asks me and says, I've got this condition, I may recommend higher doses, but that's because for specific conditions. For the average person, to get sufficient vitamin D and maintain good vitamin D status, around about 5,000 IUs is pretty much all you need. For a young child, probably 1,000 IUs, So that's the sort of stuff. We don't need to go crazy on that. There are competition between vitamin retinol and vitamin D. And then there are a whole lot of other aspects that I've discussed about, issues of conversion and issues with other health-related problems, some general information in that regard. So sometimes you can't correct a vitamin D status immediately. You may have to first fix the liver, fix, the diet, and other things like that. And if you're losing weight, you sort of have to work out what has been my sun exposure and what has been my retinol exposure in the last couple of years. That's a hard question to answer. If you can answer it, then you can probably adjust some of those other aspects in terms of the supplemental to balance those two. If you can't, you just sort of have to cop it in the chin and basically just go with the flow and see how you feel and how things pan out. Generally speaking, there is, even out of the fat cells, there is a sort of a rate limiting sort of the flux of how these get released. They don't get dumped in massive amounts. So it's not as big a problem as some people make out to, but at the same time, you don't want to be basically, poking the bear, so to speak. You want to be doing it in a smart way. But generally speaking, that's what I usually tell people, around about the 5,000 IUs and about 1,000 IUs for younger children. That's pretty much it, guys. So I hope that's sort of clarified things, sort of explained some of the types and some of the issues associated with vitamin D malabsorption, vitamin D conversion, and other related aspects. This is just sort of a general one, just covering. I do intend in future to do some more detailed stuff on vitamin D in terms of different diseases, but also how the sun, its influence, the beyond vitamin D sort of component. Vitamin D still plays a role, the fat soluble vitamin D, but it's also cholesterol sulfate. There are a lot of pathways which are involved in sort of how things function inside, which is really important, how these complex interactions are happening between vitamin D and other aspects and other nutrients and other enzymatic processes that can have an effect on people's health. So that's for another day anyway. So I hope you enjoyed this, and please share it and please hit the like button. The algorithm apparently enjoys it, and so do I. Anyway, see yous.